Okay, guys. Eric, the floor is all yours.
All right, great. Thank you so much. Give me just one moment to start this up. The event got a little bit bigger than I was anticipating when I first agreed to do it, because now there's the collaboration with Baltimore Code and Coffee. But thank you all for joining. I love Baltimore Code and Coffee, and so it's great to be collaborating with you guys. Let's share the screen here. Can you see that, Sujoi?
Yep, looks great.
Okay, awesome. Yeah, so the talk today is modern full stack development with TypeScript. However, if I was being more accurate, the actual talk title should be modern full stack development with TypeScript and a bunch of other stuff for developers who need to do everything. Of course, that is a mouthful, and Sujoi probably wouldn't want to put that as the title for anything, and I don't think anyone would want to read that. So, but this is a bit more honest about, this is a more honest indication of what we're going to be talking about. So the reality is that the full stack is more than just two things, right? Typically, I think when we talk about full stack, what we think of is front-end development and back-end development, right? This is your standard notion of what full stack is. And maybe your experience is similar to mine, where you took some, I started out learning entirely online, right? Don't have a CS degree. So, I would take online courses on Udemy or something, and you might take a course that's like, full stack development with Python or full stack development with JavaScript or whatever the case may be. And so you'll write a bunch of front-end code and you'll write a bunch of back-end code, and then the course is done. And you're like, that's it, great, yeah, full stack development, done, right? And so you have a bunch of code that works locally, but when it's time to work on production applications, particularly for those of us with maybe a bit more seniority, there's a lot more that goes into it, right? So at the very least, there's deployment, right? Now some online courses will cover deployment, but a lot don't. And this can be highly variable depending on the organization that you're working for. But deployment is a huge deal. We got to get the code into the hands of our users, or else it's not doing anything useful, right? So full stack development, in my interpretation, especially with people working on smaller teams, as I'll address in a moment, includes deployment. It includes infrastructure concerns. A lot of times, your more senior developers will definitely be involved in these things. You might even be an accidental DBA, right? If you're creating database models and you're trying to investigate why your queries are so slow and all that sort of thing, you are an accidental DBA. And that may or may not be what you think of when you think of full stack, but it certainly can be part of the job description. Then, of course, there's testing, whether that be automated testing or even sometimes manual exploratory testing. And then there are just the soft skills, particularly, again, for more senior people who might have to integrate or interface directly with project managers or product owners or whatever we're calling them these days, or directly with clients. And so I'm going to talk about most of these things, not the soft skills part, but most of these other things. And so that's what I mean by full stack development. And so in context, who is this for? So the only right answer in software engineering is it depends. So does this apply to you? Well, it depends, right? If you work on web applications, right, this might apply to you. So if you're working on systems, perhaps not so much. If you're working on small to medium-sized startups, I'm using the term startups here as a catch-all, but like smaller companies, this probably doesn't apply to you if you work for a FANG company or a large bank or something like that. But if you work on a smaller team, this might be more applicable. Developers who need to be a jack of all trades, right? So as I outlined previously, there's a ton of things that developers might be involved with. And particularly if you can't throw code over the wall, right? This is like a DevOps, a common term in the DevOps community, which basically amounts to developers writing application code and then just chucking it over to the operations team and saying like, good luck, works on my machine, have fun deploying it, right? A lot of us, myself in particular, we can't do this, and it wouldn't be a good idea to do this even if we could. But this is, again, the type of person where this might be applicable. But also developers who have some latitude to try new technologies. When I say new, I don't necessarily mean the latest JavaScript framework that was written last week. Most of the things that I'm going to talk about today have actually been around for quite a while, but new maybe in the sense of new to your organization or new ways of thinking. And that's particularly what I'm interested in, ways of thinking about full stack development. So I think it's important to have a working definition of software engineering, right? We throw this term around a lot. I like Dave Farley's definition, which comes from the book Modern Software Engineering. And he says that it is the application of an empirical scientific approach to finding efficient economic solutions to practical problems in software. And for me, that last bit is super important, right? We need efficient economic solutions to practical problems, right? And so that's what I'm going to be focused on today. My main thesis is that there's too much to do. We can't be experts in everything. We do need those efficient economic solutions, but we need tools to help remove or at least abstract away entire areas of work, right? To help make it easier for us, particularly given that we're not experts in literally everything that we might be asked to do. So how does TypeScript fit in? Well, it's the one language for most of the things, right? I think that anyone who has familiarity with JavaScript and TypeScript would know that you can at least do front-end and back-end development, but we're going to talk about some other areas. So you have your front-end development, your back-end development, that's all covered. But there's also some infrastructure as code options and some database management options, which we'll get into as well. Obviously, there's type safety, hence the name TypeScript, right? That is the main selling point that most people talk about. And also because it is, at the end of the day, JavaScript, right? You have many battle-tested libraries and packages to choose from. Whether or not they are good and help you is a different question, but there are a lot of options out there, certainly to potentially make development easier. So I think it's always necessary to answer the question, like, why do you need type safety in a conversation about TypeScript, right? Particularly for those of you who might not work with it so much these days. And so I want to use an example from my own coding experience. So this is some code that I wrote 2 or more years ago, right? I was working on a project with another local Baltimore meetup that was Charm City JavaScript, shout out CCJS. And I wanted to create a project which was basically a spoof on, at the time, what we were all calling like meme stocks, right? So the idea was to create kind of like a fake stock trading platform game type thing, you know, as a web application. And so we called it meme stock. And I had this idea for an AI stock traders that would play the game along with the human stock traders and whatnot. And so I was learning a lot about, like, you know, AI decision making for games and all that. But one of the things you'll notice about this code, this is JavaScript code, is that in the comments, I'm actually giving myself type hints. Right? That data comment, right? That is a type hint for what the data object actually is. And then there's that user stock values type hint right there. So this was, like I said, 2+ years ago, whatever it was. I wasn't using TypeScript full time. And I was already in my mind going like, it is a pain in the butt to try and like pick this up after, you know, a week of not working on it and try to figure out like, what are these types? You know what I mean? And so I pulled this project up again for this talk. And just to get the modern VS Code IntelliSense, just to look at what it says, it does give me some idea. The IntelliSense gives me some idea of what the data object is. But you can see here, while I get the key names, I have no idea what the values are. They're just any. And similarly, when I look at this user stock values thing, even though my my comment tells me kind of more or less what the object looks like, the VS Code IntelliSense has no idea, right? It's just any, right? And so the main selling point here is that as your applications grow, it becomes harder to keep track of like, what are the types that we're working with, particularly if I have to come back to a piece of code after not having worked with it for a while. It's really helpful to not have to put in a console log and run the application just to see what the type is, or have to go read code in like a bunch of different files just to get the idea of what the type is. There are other benefits as well, but again, this is just a personal anecdote from my own experience. So it's like, what the heck values am I even working with? This is, for me, one of the main benefits. Obviously, there are also entire classes of bugs that can be handled with TypeScript, or that you can defeat using types as long as you're not throwing the any type around everywhere. But the expectation is that types will save me, right? And the reality is that it's more complicated than that. And so let's dive into that a little bit more. In a common web application that you might have seen over the past 5 to 10 years, you might have a UI like single page application. And if we're being real, it's probably a React application, but it might be something else, right? So you might have like a single page application, and your single page application is going to make a bunch of like HTTP requests to a server. That is probably mostly CRUD operations. There's definitely could be some other stuff in there, but a lot of CRUD operations. That server might interact with a database you control or some third-party API that needs like security credentials or something like that you don't want to expose to the front end. But this is like pretty standard when it comes to web application development over the past, let's say, 10-ish years, right? And so you can work in a single language as we discussed before, because it's JavaScript and you have Node and you have the browser, but you need types in 2 locations, right? So if you have a separate UI application and a separate server application, then you need types in both of these locations. And in like this is like a very simplistic example, but let's just take like the most simple example you can imagine, like a read operation on a user, right? Your UI, your React SPA or whatever it is going to make a request to the server, and the server is going to return a user, but the type of the user is probably going to be the same. It's in both applications, right? Your user in this stupid, silly example is like ID full name, right? But it's like, if ID full name is all that the server is going to return to you, then ID full name is all that the UI has to work with, right? And so you need those types in both locations. And so there's this like duplication of types that we end up with. And maintaining 2 different repos in particular can exacerbate this problem, because now it's like, all right, so I got some code in this repo, and then I got to copy it and like put it over in this repo or whatever the case may be. Now, I do want to make a really important note about software design here. I am specifically talking about the scenario where the data model of the UI and the server applications are almost identical, or at least if you imagine a Venn diagram, have like serious overlap. There are scenarios where you might use slightly different data models, but this is not necessarily the audience that I'm talking to, right? But I just want to say, for the sake of completeness, that like there are patterns like anti-corruption layers, open host services, or even just mapper or gateway objects, right? That might lend themselves to having different data models for internal models for the UI and different internal models for the server and yada, 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 right? But what we're talking about is where there's like serious overlap, right? So we need types. We've established that we need types for the front end and the back end. And that CRUD operation types are generally identical. I mean, if you think about it, if I'm going to read some data from the server, then the data that I can get back in the UI is probably going to be whatever the server is expecting to get back from the database. So if I read values from the database, I'm going to create an object to hold those values. I expect the type of that object to be the same server side and client side, mostly the same, let's say. When I attempt to create a new record in the database, I'm going to pass some data from the client to the server. And I would expect that the type of that data on the client is going to be pretty much the same as the type of the data on the server. The server might inject some additional information like date created or something along those lines, but reasonably identical. And the problem is that managing types can be a chore, right? And as we discussed initially, we already have too much to do, right? So we need to be able to mitigate the chore that is managing the types in multiple locations. And so one of the key things is going to be full stack type safety, or end-to-end type safety, whatever you want to call it. We want to talk about easy code sharing, good abstractions, and tools that will do the work for you, right? Because again, we need things that will take something off of our plate because there's too much to do. So let's talk about full stack type safety with BFF, your best friend forever, which is in this case actually the backend for front end pattern. So this is one example of full stack potential full stack type safety. The backend for front end pattern basically is that you have one backend per user experience instead of having the one general purpose API. So if you think back to that example I gave of like your web application for the past 10 years, that server that you're making a request to, that is your one-stop shop general purpose API for all the things, right? And I've worked at plenty of organizations where that server doesn't just serve one application, right? It might serve a web application, it might serve a mobile application, it might also be the API for your customers to interface with the data in your database, right? So you might actually have developers working for some client of yours that want to access some database. So you're going to expose some routes to them so that they can get some data. And the BFF pattern is the opposite of that. It's just saying, like, instead of cramming it all into one place, we're going to have a different application. We're going to have a different server per application effectively. And we're going to see it's pretty easy to implement this, as we'll see in a moment. A lot of modern meta frameworks can help with this. So I've mentioned React here. I want to say, like, I'm not a React fanboy per se. I actually, if I had to choose, I'd probably do most of my development in Solid. But React is super common. It's almost ubiquitous at this point. So, but any modern meta framework could help you with this. So for Solid, that's Solid Start. For Vue, that's Nuxt, if I remember correctly. For React, that could be something like Next.js or Remix. For Svelte, that would be SvelteKit. A lot of these things can help. And so we're going to look at a simple example from a Remix application. So Remix being a meta framework for React. And this is something really trivial that I threw together. So let's look at this folder structure real quick. So this is a Remix application. We have an app folder. Inside the app folder, there's a models folder, a routes folder, and an _index.ts file. Okay. In models, there's going to be a products.server.ts file. And in routes, there's, for this demonstration, one route. Products, and inside of products, you have product.tsx and route.tsx. All right. So basic folder structure out of the way there. Now, the products.server.ts file looks like this. Again, super trivial. This is a function that makes a fetch request to the fake store API. By the way, shout out to fake store API, really useful for prototyping and doing some little demonstrations and whatnot. And we're going to make a request for products, right? If we don't get an OK, then we're just going to throw an error. Otherwise, we'll get some JSON, and we're going to parse that JSON into using a specific schema. I'm going to come back to this in a hot second, but I want to note that this is type safe, even though I have not specified any types. Like, you'll notice that the function signature doesn't say, like, specifically what this returns. I can assure you that this is type safe, and we'll see more on that in a moment. So this is the products.server.ts file. Let's take a look at the index.tsx file under the products route. Okay, there's two functions in here. If you look, skip over the loader and look at the products function. This is just a React component, and anyone who's worked with React will more or less understand what's going on in this component, right? You're going to return some JSX mapping over an array of products with using another component to actually display those products, right? Again, this is type safe. I know that we're not seeing a whole lot of types in here, but for example, if I were to hover over that products thing and use my IntelliSense, if you kind of skip over this serialized object undefined to optional thing, what you can see is that we have an object, an array of objects with a bunch of types, right? So we have a field with ID number, which is a number, a title, that's a string. There's even a nested object, which is that rating thing. So rating is an object with count, which is a number, and rate, which is a number. Okay, so these are our types. Now, I mentioned, right, that if I go back here real quick, that we're mapping over the array of products, and we're going to pass that onto a product component, which will display a specific product, right? So let's look at that. So this is the product component. It takes in a product, and it will show the title, the image, the description, the price. This is all stuff that we saw in that object that we were just looking at. And the type is a product model. We'll talk a little bit more about where these come from momentarily, right? But fundamentally, right, this product here is the exact same thing that we were just looking at in the other file, right? ID, title, price, category, description, image, rating, all that stuff. It's here. It's what we expect. This is our type safe example. Now, this is what it looks like, and this is, I know I'm wowing you with these CSS styles here, right? Now, a really simple example, and it doesn't seem that special until you realize where the fetch request is made. So as you recall, this is a single file, and we have this React component products, and we also have this loader function. Well, interestingly, the loader happens server side, and the component is rendered client side, right? And what that means is that with loaders, you have options because you don't expose secrets to the front end when you're using one of these loaders. So requests are made server side, as I mentioned, not client side. And you don't need a separate server application just to hide your secrets. Imagine using a third-party API instead of the fake store API, like a third party that required credentials or something like that. Imagine it was accessing a database. With these loaders, you have options and you don't need to create that whole separate server. You are implementing the backend for front end pattern because effectively that loader becomes a CRUD endpoint all by itself. And this is a single application. It's a remix application, one area of code that you have to change anytime you want to update the UI or change that route a little bit. Super simple, nice and easy to work with. Now you might be asking yourself, where did the types come from, right? Because I showed you that I wasn't explicitly defining types in most locations, but we still seem to have that IntelliSense. And that's where we get Zod, right? And some of you may have heard of Zod. Hopefully some of you have worked with Zod before, but it is a validation library primarily, but it's also super powerful when it comes to types. So the thing that I didn't show you in when I was looking at this fetch products function from before, right, was this fetch products response schema, right? I didn't show you what this was, but you can see that this schema is parsing the JSON, and that's how we get the types. So what is that schema? All right, so there's three things that we're looking at here. Up top, this is our product schema, right? This is a Zod object, and it's got a whole bunch of Zod validators in it, right? So you got numbers, strings, like we saw before. Interestingly, if you look at the image, it says that not only is it a string, but it's also a URL. And for count, right, that nested rating object, we have count. That is not only a number, it must be an integer, right? Zod has a lot of really powerful validators. You can get way more complicated than this. This is just a simple example, right? But the idea is that this product schema can be used to validate that the type of whatever object that we want matches what we're seeing here, right? And so that fetch products response schema is an array of product schemas, right? Note that you can also export the type, the specific type of the product by inferring it using this z.infer syntax here, right? So the great thing about this is that we have validators, which can throw an error, for example, if the object doesn't match what we were expecting. So we can validate all sorts of code with this. And additionally, we can share these types around, right? So I could export this type, I can share it around, and that's a very powerful pattern to use, right? So this is how we're implementing our sort of backend for front end using this simple remix application. So you use Zod for code you can't trust, whether that be APIs, third-party code without good types, or like certain SDKs. And I'm looking at you, DynamoDB document client. I like AWS, but some of their SDKs are a real pain in the butt to work with, and their documentation is not great sometimes. So I found that Zod is incredibly helpful there. Now, alternatively, this is going to be a short aside, right? You could start using remote procedure calls with something like TRPC. This is just an example that I pulled right off their documentation. So I would encourage you to go take a look at it. I'm not going to spend too much time on it. But on the right-hand side, there is essentially a server with implementing remote procedure calls. And then on the left-hand side, there is a Next.js application, which is going to use that data. You'll also note that there's some Zod stuff going on there. So, hey, Zod, very useful in a lot of different contexts. But using TRPC, you can still get that sort of end-to-end or full stack type safety in a different fashion if you didn't want to use Remix or even Next.js. Even though this is a Next.js application, you don't strictly have to use Next.js in order to implement that. So, that's a brief aside into TRPC. And so you might be thinking to yourself, like, well, that's all cute, but real applications need databases, right? Like all I've shown you so far is just some silly fake store API nonsense, right? And so there are a bunch of type-safe ORMs and query builders, right? So there's Prisma, probably the most popular. There's Drizzle, which is gaining popularity. There's TypeORM, Keasley. There's probably a bunch of others that I've missed. And then there's also, I should mention, SDKs for certain other services, which we'll talk about a little bit later. But let's look at a basic Prisma example, right? So we have this fake veterinary practice software that I sort of came up with, right? And this is what a query using Prisma might look like, right? So I've got this function, which is called get pets by owner. So you can imagine that if you are a pet owner, you might own multiple pets. And so if you go to your vet, there might be multiple pets associated with you. And so if you have an owner ID, you could get all the pets associated with that particular owner. And so what we see here is that we have an instance of Prisma. So that's Prisma. And then you see .pet, that is the pet table, right? So you can imagine in your relational database, you might have a pet table. And then you can do something like find many, right? Give me all the pets that match this where the pet owner ID is the owner ID that we passed into the function. And you can even select, specific columns, right? If there's more columns in that table than you actually care about, you could just select the pet ID, the name, the breed, the birth date, whatever you want, right? Now, I should note that this is a simple example. You can do things like joins in Prisma. You can do a lot of other fun stuff there. And the other nice thing is that Prisma, along with a lot of these other type-safe ORMs and query builders and stuff, Prisma can generate these types for you, right? Can generate this client for you. And so that makes it even easier to work with because I don't have to go and manually fill out a bunch of Zod stuff, right? And if I, oops, go on now, there we go. And if I were to hover over this, right, use my IntelliSense from VS Code, we can see that I'm returning a type of Prisma promise. But that is effectively an array of objects where we have a pet ID, which is the number, a name, the string, a pet breed, blah, 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 blah. Birth date and breed probably shouldn't be nullable. I don't know, just a silly example. But we get that in IntelliSense. No need to define the types. Prisma does that for me. Prisma also has some utility types, and this is something we're going to talk about the concept of utility types a little bit later. So I'm just kind of planting the seed here. But fundamentally, if we just want to say like, okay, strip all that Prisma stuff out of there. What is the actual return type of the get pets by owner function that we care about? It's really just an array of objects, right? So this return type sort of utility thing that I've got here is just stripping all that Prisma nonsense and that promise nonsense out and just saying like, really what we care about is an array of objects where we have pet ID, name, breed, birth date. Okay. Here's just one more example of Prisma from the documentation because I want to show you something that's not just a read, right? So we talked a little bit about CRUD operations. This is a create, right? So Prisma has a bunch of utility types that it'll generate. In this example, there's a user table, right? And so in order to create a user, Prisma will give you a type that says, if you want to create a user, then the object that you pass to Prisma must satisfy this type, right? So in this case, it's Prisma.user create input. So it's the input required to create a user. And this type comes directly from Prisma. Again, don't have to type anything up ourselves, which is great. And you can see here in the code that all the way at the very end, we're going to create the user by awaiting Prisma.user. Again, user is the name of the table. Prisma.user.create, and then pass in that data. We already know that the data satisfies what Prisma is expecting because we said that it is that Prisma.user create input type, right? So utility types, type generation, these are really important to us. We have limited time in the day. I don't know about you. I don't want to spend my whole day writing types. And I think this is the key here is that writing types does not create business value, right? The users fundamentally don't care about your types. They care about, does your product do some useful work, right? So the less we can write types and the more we can lean on type safety, I think the better off we are. Opinion, but I think a lot of people would agree with me on that. All right. So not only will Prisma and some of these other tools like Drizzle and whatnot handle interacting with your database, but they can also handle DB migrations. Now, as I mentioned at the very beginning of the talk, you might be an accidental DBA, right? Which means that you might be doing database migrations and all that. And so using a lot of these tools and there are other tools, obviously, you can actually handle your database migrations in a setting that doesn't require you to necessarily write some SQL or do anything janky with other libraries outside of the TypeScript JavaScript ecosystem. And so that's just a bonus for us, taking some work off our plate. But now if you still need an API for your database, okay, there are some scenarios you'll recall before I was talking about the case where a user or your clients might need access to the data in your database, right? So that's where something like Postgres comes in. Now, Postgres is not TypeScript specific, so I just want to put that out there. But if you recall at the beginning, I was talking about tools that can like take work off our plates, right? One of the nice things about a tool like Postgres, and there's other similar tools out there, is that it creates a server for you that effectively implements a RESTful API for your specific database, right? Super easy to set up. It's got all these operators. So you can see here, this comes directly from the Postgres docs, right? All these operators that you can use as part of your HTTP request to get stuff from your database. Yes, you can do joins. You can do all sorts of fun stuff in there. And because Postgres has a Docker image, like an official Docker image, it's super easy to get started. Obviously, this is like a trivial example that comes from the documentation, but you can see that we have a Docker image for the Postgres instance. And on top of it, at the bottom there, you can see we also have a server for a Swagger UI interface. So this means that with something like Postgres, not only do you get an API that works with your database, but you also get documentation, which means that if somebody wants to know like what are the expected values that this endpoint will take, you can just point them to the Swagger UI documentation, because Postgres will generate an open API schema for you. And so that's super powerful. So you can imagine if you had a specific Postgres user that was set up with access to just a limited number of tables or something like that within your database, you can just set that up as the user for your Postgres instance, and away your customers go, right? Super powerful. Tools like this, really useful. And speaking of Swagger and OpenAI, if you have third-party APIs that you're consuming that also give you a Swagger or OpenAPI documentation, you can generate types from something like OpenAPI TypeScript, which again helps you to not have to manually type everything out. It can be very powerful for taking some work off your plate. Now, what if you don't want to manage a DB? Now, I mentioned before, again, we're not just concerned strictly with TypeScript, but we are concerned with tools that will help us do our jobs more efficiently, and let's be more pragmatic about it. There are a lot of tools that can help you manage an entire database, right? So there's something like Pocketbase, which uses SQLite, Supabase, which is also a Postgres database solution. And then there's PlanetScale, which is MySQL. The nice thing about this is that these will have, TypeScript SDKs that you can use to interact with their services. And so if you don't want to spin up your own database and do all that rigmarole, you can lean on a lot of these technologies to get that database going for you, even handle some database migrations, handle real-time updates. There's a lot of really cool features, things that we can leverage to kind of take that DBA role off our plates. But databases aren't the only thing that we need to manage, right? We have infrastructure. And so there are TypeScript infrastructure as code solutions. So if you're using AWS specifically, there's the CDK, the Cloud Development Kit, which is a TypeScript infrastructure as code solution for AWS. If you need something that's more general, there's Pulumi, which has a TypeScript SDK along with some other SDKs as well. I think like C# and Go and some other stuff. So these are solutions that would help you to manage your infrastructure without needing to learn Terraform or CloudFormation syntax or whatever the case may be. And so again, even if we have that role on our plates, we don't necessarily have to go outside of the TypeScript realm to get that going. And so here's just a really simple example from the CDK documentation. You can see that this is going to create a CloudFormation stack. And the things to note are really just that queue, that topic, and that subscription there. So the queue is an SQS queue. The topic is an SNS topic, and then you can subscribe to that topic. The queue can subscribe to that topic. And so this is just a really great way to get started using AWS services without like doing a super deep dive into like CloudFormation or Terraform, like I said, some of those other things. Here's an example from Pulumi. Not going to go through it like line by line, obviously, but again, I just want to show you that it is possible to generate even complicated things like ECS clusters, application load balancers, entire repositories, specific image instances, Fargate services, all of this stuff. It is possible to do this within the TypeScript realm using some of these tools here. And that's really great for us because it means that if I can't throw code over the wall, at least I can use tools that work with the technologies that I'm already familiar with and with programming language that I'm already familiar with. Now we have to tie it all together. And for that, I think that a great tool that is going to come up time and time again is going to be a modern monorepo. Now, this is again, not really a TypeScript specific thing, although I will focus in on one tool that has a lot of TypeScript support. But the two big players in the JavaScript ecosystem these days, I would say that at least the ones with the most mind share are Turbo Repo and NX. I like both of them, but let's look at an NX example really quick. The reason why I want to focus in on NX is because NX is very extensible using TypeScript. So you can extend NX's functionality just by writing some TypeScript, and NX is all in on TypeScript. So in a simple example, this this comes off of their docs, right? But you have this application, this repo that they're calling package based, right? That's the name of the repo. So that's the root directory there. Then you have multiple packages. There's an is-even package and an is-odd package, okay? So that's the important things. Each of those has their own index.ts file, yada, yada, yada. Now, again, this is all about code sharing. This is all about tying together some of these pieces that we have, right? Some of these different technologies that we're using. So you can write your own packages, as we've seen here. This is the is-odd package. And if you look at the dependencies section, is-odd depends on is-even, right? Which is another package that we've written. And you can import directly from is-even any of the exposed functions or classes or whatever you want, right? So this means that, let's take an example from earlier. If you had a Prisma client and you had some configuration values for your Prisma client or whatever, you can just export a configured Prisma client for use in multiple applications using this sort of monorepo strategy here. It's really great for code sharing, makes things so much simpler, and no more NPM packages for internal code sharing, right? Which I can tell you, having done that, total nightmare, absolutely hate it. Having a shared NPM package for multiple repos and whatnot is a real pain in the butt to maintain, at least in my experience. So getting close to wrapping up here. We also want to be able to test. I mentioned testing before. So we're talking about a couple of really popular libraries these days. So there's VTest for unit and integration testing, and then Playwright and Cypress for end-to-end testing, right? Now VTest, right, is a just compatible API just with better TypeScript support. So this is an example from their docs, which basically highlights how sort of like types, how you can work with types a little bit better in VTest. You don't need configuration out of the box to use VTest with Jest. It's a little bit harder to get set up using a TypeScript project, which is why VTest has become so popular, right? But as far as unit integration tests going, VTest is absolutely the way to go. And again, TypeScript. Like we're all in on this thing. We're doing everything, and it's really much better to work with when the tools help with the configuration step, because otherwise it can be a real pain in the butt. And in fact, I have a word of caution here about about TypeScript and tooling. Modules can be a little bit hairy. So right now there's kind of the battle between CommonJS and ECMAScript modules. For those who might not be familiar, ESM is the native solution for JavaScript modules, but it is a more recent development, and historically CJS has been much more prevalent. And in fact, it was kind of like the default solution for Node applications for a very, very long time, right? And even the TypeScript documentations say that you might want to use CommonJS as the default, right? Which is funny because if you do a quick Google search, you'll see that a lot of people are suggesting use ES modules wherever you can, right? I didn't ask ChatGPT what it thought of the subject, but I can only imagine that it's going to come down with some reasons one way or the other. But the truth of the matter is that the difference is not trivial, right? So if you have an application that's already using CommonJS and you want to move it over to ESM, if you look at these bullet points here, like there's a bunch of things that you might have to take into consideration if you're trying to move over to ESM, right? And additionally, if you're trying to create a TypeScript project that outputs ESM, it's not just a single line in tsconfig. I think that was naively what I was hoping that it was going to be when I first, was thinking about moving over to ESM. You literally can't just change the module to be like ESM and like, here we go. There's a whole bunch, if you look at these bullet points here, there's potentially a whole bunch of other steps that you would need to implement. And so this is just a word of caution. Tooling has gotten much better in the TypeScript ecosystem, but it's not perfect. And particularly, you might have to wrestle with the CommonJS versus ECMAScript modules dichotomy. And that is unfortunate, but we haven't solved all our problems yet. So on that note, let's forget about our problems. We're going to bring it back home, try to wrap up here. And I want to go back to the conversation about types. Now, we started off, with a conversation about like why types and type safety are useful. And so I want to talk about some native TypeScript utility types. You'll note that I talked about Prisma utility types, and other SDKs and stuff have their own utility types, but there are some native TypeScript utility types that are going to make your life a whole lot easier. So get familiar with them. The docs are pretty good. So there's the partial type, which sets properties to optional. There's the record type, which is just kind of like an arbitrary key value record, which can be really useful in some scenarios. There's pick, which allows you to pick a subset of properties from an object, for example, from another type. And then there's omit, which allows you to omit some values from a specific type. And so let's look at a quick example, right? You'll recall when I was doing that fake pet application thing, we had like a product, right? Or sorry, I think it was the fake store API thing. We had a product, right? And the product had things like, the title, the description, the ID, the price, all that sort of stuff. Well, if you wanted to just have a subset of those properties on the type, you could use something like pick. And so that's what we're seeing here. You're going to pick from product the title, category, and description. And you can see that this new type that we've got here is just going to be title, category, and description. So very useful. Additionally, you can do something like omit. So this is just another kind of like silly example, but imagine if you wanted to have a combination of that product with a store ID, right? So you might imagine that a store will have many products. And so you might want to have a type that represents the product plus the store ID. And for whatever reason, I'm omitting rating just because I can and because it's for the sake of demonstration. So here's like an example with that. So we have an omit with a union. And you can see here that I've tried to create a store product, right? But it's giving me a little squiggly, the little squiggly of death, which means that I've done something wrong. And if we hover over that to get our IntelliSense, we can see that it's telling us that store ID is missing, right? Because while we have the ID, title, price, category, description, and image from the product type, and we're omitting rating, so we don't need that, we didn't include the store ID. And so again, this gives you, the utility types gives you ways to combine types, to pull little pieces of other types rather than having to like define them. And it couples the types together, but that can be extremely useful in some scenarios. All right, so what have we learned here? So we're going to say that using TypeScript and modern tooling, we can have end-to-end type safety or full stack type safety. We can do database management. We can have infrastructure as code. We can have easy code sharing, easy testing at all levels, and only minor headaches with modules, right? So in conclusion, there's too much to do. Don't be a hero. Be pragmatic. Use the tools that are going to help you get the job done. We've demonstrated a lot of them today, but there are many more that I haven't had time to cover. So thank you very much. Really appreciate it. You can connect with me on LinkedIn. Feel free to, it's Masi, right? And I really hope that you got something useful out of this talk. And I think next we're going to have some questions.
Well, that was awesome, Eric. That was a great breakdown, a lot of tools and everything. That was great. So I'm gonna leave it to the floor. So if anybody have any questions, if you could raise your hand, I could unmute you and you could ask the question to Eric. That'll be great. Or you can even put it down in the chat if you're interested of any questions. I can read it out and then Eric could try to answer it as best of his ability. So wow.
I'll try my best.
I have a question for you, Eric. So how, like, your background was music, right? How do you motivate yourself? Because I'm like a little bit of a business kind of area. How do you motivate yourself to be a senior without having an academic background? Like, who was your inspiration, and how did you go through that process? And what kind of hurdles had to go through to become a senior software engineer?
Let me see if I can answer this succinctly. All right, so you brought it up just so everyone's aware. Like, I don't have a CS degree. I have a music degree. I actually never even used my music degree because I went and pursued other things. I had like a weird winding career trajectory that eventually brought me to software after many trials and tribulations. I think that, so there was a question there of like motivation, inspiration, all that sort of stuff. So I think, for whatever reason, I just like software development. I think part of it comes down to the fact that there's always new challenges, things to learn. I would describe it as the complete antithesis of transactional work. So if you imagine transactional work like being a cashier or something, and like no hate on cashiers, I definitely had cashier jobs in the past. If you think about transactional work like a cashier, like you scan an item, you take some money, it's roughly the same thing every time. Software engineering is the complete antithesis of that, right? A lot of new problems, a lot of new hurdles, a lot of new challenges, and I find that to be pretty exciting. So it's easy for me to be motivated when the work is evolving like that. I think that's just something about the way that I work. As far as like sort of what motivated me, like how did I get to this point? So I will tell you that the main motivation was actually my own mistakes, right? So when I first started out, I was making so many mistakes that, and particularly you'll notice that I shared that code snippet from like 2 years ago, whatever it was. Particularly when I would have to come back to code that I wrote like 6 months ago, a year ago, or whatever, I always found myself going like, what the hell was I doing? This is so stupid. Like, I can't understand any of this crap. And I wrote it. I'm the only one to blame. And so I think I was just really trying to push myself to learn more in the hopes that I would somehow be able to write like perfect software the first time around. I don't think that's possible anymore, but I'm motivated to try and improve so that I'm at least not disappointed with myself when I go back and review my code 6 months from now. And then I would say, like, lastly, as far as like, think people that I look up to, I really look up to a lot of the people that have sort of like come before us and laid the groundwork. So obviously you got your famous people like your Bob Martins and your Kent Becks, but I've really found Dave Farley's work with continuous delivery to be quite inspirational, certainly filling in a lot of the gaps. I think that there's a lot of I think living in this sort of like internet personality influencer age, there's a lot of people online that do some really interesting work and will let you peer into the life of a Netflix software engineer or like whatever the case may be. So I find it to be exciting because I get to learn from great minds without like from the comfort of my own office chair, right? So hopefully that answers your question. There's a lot.
Yeah, that did. Yeah. That's great. So I'm just going to dive. There's some questions here on the chat. Let me go ahead and read. So, would you explain what to do to avoid using npm package to each local repo? It creates so much issues every time working on a project with a team. So that came with Joyce.
Yeah. I'm not going to lie to you. The only solution that I have right at this moment is the mono repo, really, because just a background on this. VitusVet as a company has existed for, I don't know, 8 years, 10 years, something like that. And so we have a lot of different applications, and particularly a lot of the decisions that were made were to separate things into separate repos, right? So you have like a UI repo for one application, and then a backend for that for that application, and then you have another application with a repo with the UI and blah, blah, blah. And so what we had to do is like, we would create an NPM package that would be shared UI components for like multiple React applications. Huge pain in the butt, right? It's really, really painful. Okay. So the only kind of tips that I have are, so the first tip is if you can use a mono repo, that is going to help you out tremendously, because you're bringing all those applications much closer together, and that you don't have to publish the packages to NPM in order to be able to use them across applications within your mono repo, right? So I think that's where that tool really comes in handy. And the mono repo tooling is not just about like co-locating files, right? There's ways of running scripts across multiple applications simultaneously. There's a whole bunch of other fun stuff that comes along with that, right? So the mono repo solves that problem by allowing you to bring those applications closer together and just using those packages internally without having to export them or anything like that. Now, if for some reason, if you can't do that, and that's reasonable for organizations that have existed for a while, at least if you can't do that overnight, I think that one of your best bets is to try, particularly if you have like shared React components or something like that, is to really nail your testing, or try to get, try to do as good a job with testing as possible, and potentially look at a solution like Storybook. There are some solutions out there which are aimed at being able to share libraries and components and stuff like that. Storybook off the top of my head is just an obvious example, but I would say like nail the testing, look at some of those tools that can help you managing libraries effectively, because that's what you have. And I think that's probably your best bet if you can't migrate to a mono repo right away.
Cool.
Hopefully that helps.
And then Federico's adding to that question, the beginning path. The beginning path has a lot of content. Besides working for a company, how can we get that jump from an entry to a mid-level production code?
Besides working for a company. So that's kind of an interesting, besides working for a company. So I think that we were talking about motivation before, like how do you get motivated, right? If your company doesn't have the opportunities to kind of expand into some of these other areas, which is reasonable. I've definitely, my first job did not have any opportunities for back-end work, right? So I started off completely front end, and it just wasn't in the cards, right? And so I ended up having to go to another company to get that experience, right? But I think that it's important to be able to find some internal motivation to learn those topics, right? And depending on who you are, that might come from a number of different sources, right? So for example, I mentioned that I had worked on that sort of like meme stock project with some other developers at Charm City JavaScript. I think that if you're the type of person who finds motivation from collaborating with other people, then you would look for opportunities to collaborate with other people outside of work, whether that be through a local developer meetup like Charm City JavaScript or Baltimore Code and Coffee, or you could look for, there's a lot of like Discord servers out there for peoples in certain communities that you can try to hook up with. Everyone always brings up the open source, right? Like, do some development for open source. And I think that's a good avenue. I think that for a lot of people, it's intimidating, and maybe you just kind of want it to be a little bit more fun, and you don't want to have to worry about like people actually using your stuff and maybe it'll break or whatever the case may be. So I think if you can look for those sort of like low stress opportunities to collaborate with other people, that can be really useful. Otherwise, if you're just the type of person who can maybe dedicate like a block of time, maybe like 1 hour every day. So like, I'll tell you, my routine is in the morning before work, just for me, usually dedicate an hour to learning something, right? And so I'll give it like right here on my desk, I have a bunch of books. This is Grokking Simplicity, which is a great book, which kind of gives you an introduction to functional programming thinking. I've got Grokking Continuous Delivery. I like the Grokking series. So being able to dedicate, some time just as a habit, I think is useful for learning those skills. I know that's hard depending on your life circumstances, right? If you have children or, whatever the case may be, it's not always easy. Unfortunately, it's like we got to find the time to, we got to make the time to do these learnings. The other, I'm going to show up here in just a hot second. The other thing that I could argue, and this is, depending on who you are, this might resonate with you. When I had that front end only job, I wanted to be so good that I could get all my work done in 4 hours, right? And that has been like, it's like a weird thing in my brain where I'm just like, I want to be so good that I can get all this work done in like no time at all. And then I can just use that other time to focus on things that I'm interested in, right? So I don't know how you feel about that, but like one of the things that I would always try to do is like get so good at my current job that I could do it like super quick, and everybody was like happy with my performance, but it really didn't take me all that long. And that really helps if you're working from home in particular, where nobody's looking over your shoulder. But I found that being so good at your current job that you can like knock out tasks really quickly and then spend some of that time on yourself can be useful. But we can debate the ethics of that or whatever another time.
Gotcha. Well, that's excellent. So we only have 1 more minute till 1 o'clock. So I just want to end it there, but I want to thank you, Eric, like taking your time, your free time, and come and talk to us. Appreciate it. That was an excellent presentation, by the way. A great breakdown with all the technologies. There's a few more questions here. If you guys could email it to me, maybe I could, maybe if Eric, are you willing to answer any questions and maybe an email or sort?
Yeah, sure, no problem.
If you guys email me to syntaxorus@gmail.com, and I could see if Eric could forward it. But that was, again, I want to thank you so much, Eric, for coming to talk to us. It was excellent. And I hope you have a great Saturday, guys. I don't know where you guys are over the world, but Maryland's pretty sunny day today. I don't know what the temperature is, but yeah. So thank you so much, guys. I hope you have a great Saturday.
Yeah, thanks everyone.